Alright guys, today we got another easy lesson, multiplicity of the zero. So the multiplicity is just how many times that zero actually solves your polynomial. So if you write your polynomial in factored form, you might have x plus 1 times x plus 1. Well, that'd be x plus 1 squared, right? So that'd be a multiplicity of 2 because the negative one would solve it twice. Let's check it out. So here, if we write this in factored form, you could graph it and find your zeros. That's fine. I'm just going to factor it because, well, I see a GCF of x. And I see that that's left me with x squared minus 6x plus 9, which I know that factors as x minus 3 times x minus 3. Okay. So as you see, we have x minus 3 twice. So that means I can rewrite this as x times x minus 3 squared. So our zeros would be, obviously, what makes these things zero. So we remember to solve a function by factoring. We set each term equal to 0. We did that with the quadratics. Now we're going to do the exact same thing except with any polynomial function. So it's just extending what you already know. So what makes x equal 0? Well, 0. What makes x minus 3 0? 3. 3 minus 3 is 0. So you need to find out what makes these 0. So our zeros are 0 and 3. The multiplicity of 0 is, well, there's a power of 1 there, so 1. If I spell things right, I hope. Yeah, so on the 3 right here, that has a squared, so our multiplicity is going to be 2 for that 0. So we have 0 with a multiplicity of 1 and 3 with a multiplicity of 2. We'd write that 0 multiplicity of 1 and 3 multiplicity of 2. So that's one way you might notate it. Now, let's say you don't remember how to factor. Well, that's okay. You can still solve the quadratic, right? Oops. Let me pause it for a second, pull up my calculator. Be right back. All right, got my calculator. So once I factored out that x, I saw I have this nice quadratic here. Mode 5, 3. And it's got coefficients of 1, -6, and 9. It says x equals 3, and that's it. So if it just gives you one number for your x's, it's not x1, x2 right here, that's a double root. Remember how we talked about the discriminant and one real root, two real roots, etc. Here's your one real root case. That's a double root. So if you have just one answer from your quadratic formula, you have to write it twice because remember there's x squared. There's two answers here. Okay? Let's look at another one. X cubed minus 6x squared plus 9x. So we're going to graph this thing. We're going to graph it and see what it looks like. X cubed, oops. X cubed minus 6x squared plus 9x. Okay, this is what we got. I'm going to go ahead and just snap a picture of it. I'm going to stick it right here. Okay, so this is the exact same function we had a minute ago. X cubed minus 6x squared plus 9x. See, x cubed minus 6x squared plus 9x. So we know our zeros are 0 and 3 with multiplicity of 1 and 2 respectively. What's going on at those zeros? So if we look at the 0, it's just going right through it, no problem. But if we look at 3, it's bouncing off of there. You see that? So depending on who your teacher is, this is usually cross. That's what they call that. If it's an odd multiplicity, it's going to cross through your axis. Why do I keep doing that? Wow. Depending on who your teacher is, though, here they might say touch, or they might say bounce. I use bounce because it's visually representing what it's doing. Yeah, sure, it's touching it. What does that mean exactly? Yeah, it's tangent to the line. Who cares? It bounces. You're going to touch it, and you're going to hit it. You're going to go back the other direction. So if you have an even multiplicity, it's going to bounce or touch. If you have an odd multiplicity, it's going to cross through your axis. Put this in front. So for each 0, if you look at it, you can see, okay, it's 0 with multiplicity 1, so I know I'm going to go right through my axis there. 3 with multiplicity of 2, I'm going to hit 3, and I'm going to come back up. So we can actually sketch what this is going to look like just based on in behavior and these zeros with their multiplicities. So I know it's an odd polynomial with a positive leading coefficient. So that's down, up. So I know I'm going to start somewhere from negative infinity. So let me just get something on here. So another thing, your y-intercept, you can plot that real easy. Plug in 0 for x. It's whatever your constant term is. In this case, it's 0. So I know 0, 0 is going to be my y-intercept and one of my zeros. So right there. And then 3. 1, 2, 3. I got a 0 there. So I know I'm starting at the bottom, going this way somewhere. I don't know anything else what's going on here. I know it's going to do this. And I've got to go hit that right there somewhere. So I need to come back down at some point in time. I don't know where, any idea. But I know I have to do this. And it's an even multiplicity, I'm going to bounce off of it. And now, oops, that's terrible, whatever. I'm matching my end behavior. And this has to be something what my graph looks like. Let's see. Yeah, see, it's 1, 4 is my maximum, my relative maximum. You can't figure that out without calculus, so don't worry about it. But you can sketch the general shape of it right now. Okay, here we go. This one's already in factored form for us, so we're just going to state the zeros and their multiplicities. So all we have to do is say what makes each of these factors equal 0. I'm just going to write it underneath. X plus 7, well, that means a negative 7 is required. So I have a 0 of negative 7. Multiplicity is right there, 2. What's it going to do? That thing's going to bounce. All right, 2x plus 1. Now, this one's a little tricky for some of you. If you have to, write it out and solve it. Subtract 1 from both sides. And divide by 2. X is negative a half. So x is negative 1/2. That's my 0. I'm looking at it. There's an understood exponent of 1 there, so my multiplicity is 1. What's it going to do there? It's going to cross. Yeah, I spelled it right that time. Now this last one should be pretty easy. 4 is what's going to make that 0. Has a multiplicity of 3. Odd multiplicity, it's going to cross. Even multiplicity bounces, odd multiplicity crosses. So we could sketch this thing too. And let's do that. Let's sketch it, and then we're going to type it in decimals and see how close we are. So let me get my axes here. Now I got to figure out what my leading coefficient is going to be and what my highest degree is going to be. Well, I've got leading coefficients here of 1, 2, and 1. 1's being squared, so that's 1, times 2 is not doing anything, so 2, times 1 being cubed is still 1. So 2. My leading coefficient's 2. So 2. And then I got squared, so that's x squared times x is x cubed times x cubed is x to the 6th. So 2x to the 6th. That's what our power function, as it's called, is going to be. That's going to tell us what our thing's going to look at, like at the extremities. Now, let's see here. It's even and positive. So that's going to be up and up. It's going to be up and up. Right? Yeah, that's tilted that way, that's tilted that way, whatever. Let's go ahead and plot our zeros. -7. So 1, 2, 3, 4, 5, 6, 7. I got a 0 there. And go ahead and do this. 1, 2, 3, 4. I got a 0 there. And put my zeros in a nice dark black color so you can see them. So I got a 0 at -7. I got a 0 at 4. And then at -0.5, I have another one. When I said 7, I meant -7. Now I know it needs to be up and up. So something's going on. I don't know exactly what's going on between here, but I got to start up. Might have some sort of wiggly thing like this going on first. I don't know. But I know it's got to be up here. And I'm going to bounce off of that thing. So I got to bounce. I don't have any idea what's going on here between these things, but I got to cross this one. Ooh, I could figure out what my y-intercept is by plugging in 0 for x. It's going to be ridiculously huge, but we can see that. It's got to be the 7 squared times 1 times -4 cubed. We just plugged in 0 for x. This is not -3,000. Okay. Okay. Yeah, we're not going to go way down there. But you could go, yeah, -3,000 somewhere around there. And then we got a cross here. So I'm pretty sure it's going to have some other weird stuff going on in between here. This thing goes really far down, so who knows? But the general shape should be something like this. Let's find out. Not this lesson, but in the near future, you will have to do this yourself. So I figured I'd expose you to it. For now, I'm going to let you just use Desmos. Yeah, this thing's pretty redonkulous looking. Can't even see what's going on here because it's so crazy. Yeah, so it bounces off of here and it goes way high up and then way far down. But you can see the end behavior of it. It's crossing, it's bouncing. Bouncing, crossing, crossing. Yeah, this thing's just ridiculous. No idea. It's still going up. Well, we can kind of almost see the top of it. We're getting there. We're getting there. You can see it's got a maximum in there somewhere. Yeah, not worrying about it. Moving on. Same thing here. Okay, you can do it by hand, factor out the GCF of x squared, then it's a nice quadratic. Throw it in decimals. Let's go. X to the 4th. Let me just do this. So again, I am letting you use those for this lesson, so don't worry about having to factor everything. You could, but you don't have to. So we're using this to get our zeros. Okay? -2, 0, and 4. -2, 0, 4. Looking at the picture, we can tell what's going on. At -2, it's crossing. At 4, it's crossing. At 0, it's bouncing. So you do a little bit of puzzle games in your head. I know that my total multiplicity has to add up to my degree, has to add up to 4. These have to be odd numbers, so the options are 1, 3, 5. I can't use 5 because it's bigger than my freaking degree. 1, 3, yeah. 2, 4, okay. Obviously, it's got to be 1, 2, 1, right? Because if I choose 3, then just 2 right there, that's 5. That's too big. So 1, 2, 1 it is. Now, if the thinking's a little hard for you, just use synthetic division. Oops, oh, that, I need that. So we saw that 0 was the one giving us trouble. So let's do that. 1, -2, -8, 0, 0. Bring it down, multiply, multiply. Yeah, okay. That's my remainder. Keep going. Let's try 0 again. Bring it down, multiply, combine, multiply, combine, multiply. This is not there anymore. That's my remainder. Now, if I tried using 0 again, it's not going to work. Watch. Let's see. Do I have a multiplicity of 3? So far, I have a multiplicity of 2 because it worked twice. -8 will be my remainder. That ain't working. That's not a remainder of 0, is it? So 0 did not work. So that means our multiplicity of 0 is 2. And you could go ahead and do the other 2 zeros, -2. Why not? This should work. And there we go, a nice remainder of 0. And that's x minus 4 equals 0. You should be able to solve that in your head. If not, whatever. Might as well. We're doing it. We're doing it. If you try to use -2 again, it's not going to work. We're out of spaces anyway. Yay. And there we go. So you can use synthetic division to see how many times your zeros solve your polynomial, which is what your multiplicity is. How many times does it solve it? 0 solved it twice in this case. As you saw, I did not solve it 3 times. So all multiplicity is 2. Now what if we need to go the other way? We know our zeros and their multiplicity, and we want to find the function. So I'll just write it down what it tells you. X has a 0 at -6 with a multiplicity of 2. X equals 2, multiplicity of 1. That's what x equals. Write it out as factors. Multiplicity is my power. Plus. So now this would work, but it's not the only one. It's a polynomial function. You can multiply this by anything other than 0, obviously. And anything that's no imaginary numbers, no fractional powers, nothing like that. Keep it a polynomial. You could multiply this by any monomial that's a polynomial, and it would satisfy this particular problem. So there's infinitely many answers here. But this is the simplest one, so that's what we're going to go with. It says standard form. Well, you know what that means. Multiply the dang thing out. So write it out. X plus 6 squared means x plus 6 times x plus 6. Distributive property. X times this, X times that, 6 times this, 6 times that. Now we got this thing times x minus 2. Always simplify before you multiply. That way you save yourself some headache. You can still do it, it'll still work. It's just going to be twice as much work for you. Take the time to simplify. All right, so we have this trinomial times this binomial. We better have 6 terms whenever I'm finished distributing. Everybody in here gets multiplied to everybody in there. Let's go. X cubed minus 2x squared plus 12x squared minus 24x plus 36x minus 24x. Wait. Hang on, guys. Sorry. I went backwards here. Rewind. So I did this times those two, so that's that one and that one. I did this times those two, that's that one and that one. I did this times this one, I need to do times this one, minus 72. Sorry. 1, 2, 3, 4, 5, 6. Okay, that's how many I should have. So if you ever get lost, just go back, piece by piece. And I lost my little, oh, there it is. Combine your like terms. They're right next to each other, so that's nice and easy. X cubed plus 10x squared plus 12x minus 72. Let's graph it. Let's check and make sure it's working for us. X cubed plus 10x squared plus 12x minus 72. Now I should have negative 6 with a multiplicity of 2 and 2 with a multiplicity of 1. Negative 6 is bouncing, 2 is crossing. We're good. There we go. So again, this is a possibility. It's not the only possibility. You could multiply this whole thing by 3 and it'll still work. You can multiply this whole thing by x and it'll still work to solve these particular conditions. Later on, you'll be given more conditions for it to satisfy, so there'll be only one correct answer. Right now, we're good. Just multiply those zeros out. So let's take everything we've talked about and shove it together in one problem. Now, interestingly enough, the only thing you can't do without a graph is on the left side here. You don't know how to do your turning points without graphing. So we're just going to graph. That's actually calculus, so we're not worried about that. And you can't do the increasing and decreasing intervals without your turning points. Everything else, though, you can do just by looking at this thing. Domain, polynomial function, all real numbers, done. Range, odd polynomial function, done. Now, if it was an even polynomial function, you again need your turning points, so we couldn't do that. Actually, if it was quadratic, it's still the vertex. But for the most part, you should be looking at the graph anyway. Zeros. Well, you can use decimals to get your zeros nice and easily, but you can also factor this thing. That's going to have they all have a GCF of x, so that's going to be x equals 0. It's got a multiplicity of 1. So let me just write that out here. I'll factor out an x. Again, you do not have to do this. You will be allowed to use decimals for now. Factor this, AC shortcut, quadratic formula, work backwards, whatever you got to do. I'm going to just factor the dang thing. So I can see my zeros are going to be 0, -2, -4, all with a multiplicity of 1. In behavior, positive leading coefficient, odd degree, that's down and up. Parent function, x cubed. Oh, now to graph it, you could not, you still need these guys. Okay. So now is where we need Desmos. So all that other stuff you can do without Desmos, but it's a lot easier to do with Desmos. Because as you see, your zeros are -4, -2, and 0. Each has an odd multiplicity. Degree is 3, so the multiplicity has got to be 1 each. Excuse me. Now we can actually do the maximums and minimums. Couldn't do that before. So those are your turning points. Remember, the maxes and mins are collectively called extrema or turning points. So we're going to round to the tens place, -3.2, 3.1. And that right there was a max, I do believe it was. And then we also have this one, -0.8 and -3.1. That one was a min. So now I've got all I need from the graph. I can do my domain, my increasing and decreasing intervals. So from -infinity, see, I'm looking at my end behavior here, from -infinity until my first turning point, -3.2, it was going up, it was increasing. And infinity symbol. So from -infinity to -3.2, I'm increasing. Is that my only one? Probably not. I don't know yet. But I do know from -3.2 until my next turning point, I'm going down. So -3.2 to -0.8. Then I got to be going up from -0.8. And I don't have any more turning points, so it's got to be going to infinity. Let's check. So, yeah, if I'm going increasing until -3.2, and then from -0.8 to infinity, I'm increasing. Yep, in between there, I'm decreasing. Cool. So once you have your max and your min, you don't even really need to look at your graph to find your increasing and decreasing. You can just read it right there. You know your end behavior, so it's got to start going increasing. First turning point, looking left to right, so which one has the smallest x value? I got to bounce, got to go the other way. And I'm just going to take a picture of this. Why not? So that is pretty much it, guys. We're doing the same stuff. We're still using Desmos. Just going to add a little bit more with those multiplicities. I might ask you for the zeros. You tell me the zeros, you tell me the multiplicity. I give you the zeros and tell you, give me the function. But as far as new stuff, multiplicity is it. See ya.